Thanks everyone for joining today. We are going to be jumping right into the webinar. Today's webinar is focused on waste to resource. How can we leverage opportunities to extract resources from existing mine waste? Waste is a fairly broad topic. So for today's conversation only, we're going to be focusing on byproducts and mine waste specifically. I'll get started with introductions, and I'd love to have Ty, Elizabeth, and Ryan to quickly do introductions, and then we'll get into our agenda. I'm Batchameg with Nomadic Venture Partners. We're an early stage venture capital firm specializing in metals and mining innovation. We believe the world is going towards a more metals and minerals dependent society, which we call the metals transition. We actively invest in pre-seed, seed stage technologies across the entire mining critical minerals value chain, anywhere from exploration technologies down to technologies that can be used to tackle mine tailings to remediation work. So really excited to have you all join today. I'll pop it over to Ty for a quick intro.
Hey, Meg, thank you, and welcome everyone. My name is Ty Churchwell, and I work for Trout Unlimited. We're America's largest and oldest cold water river and public land conservation organization, and I can share more on that in a moment. But I work for our government affairs team. We're based in DC as an organization, and I oversee our mining policy portfolio.
Wonderful. Elizabeth?
Hi everyone, thanks for joining us today. I'm Elizabeth Hawley. I'm a professor in the Mining Engineering Department at Colorado School of Mines, jointly appointed also in the Department of Geology and Geological Engineering, and a fellow of our Payne Institute for Public Policy. And I work on the technical and socio-technical aspects of mine development. We've done a lot of research recently, funded by the National Science Foundation, as well as industry partners and other government agencies on waste to value. And so I'm really looking forward to today's conversation. And I have to say, I know Batchameg, we've gone back and forth about various dates, and I'm so glad this finally worked out. And I'm delighted to share the opportunity with Ty and Ryan, both of whom have become friends through this journey on this topic together. So thanks a lot.
Wonderful. I'll do a quick intro and then Ryan can go into more details when he's on camera. So Ryan is a co-founder and CTO of Vectors, an exploration technology company leveraging copper isotopes, which I'm sure he'll go deeper into. And just for context, they are a portfolio company of Nomadic Venture Partners. So I'm excited for them to share what they've been up to. All right, so we'll go into our main topic, which is tackling mine waste as well as unlocking resources from byproducts. As we all know, critical minerals plays a vital role in our modern society, anywhere from our laptops to iPhones to the energy transition to national security, all depend on the metals that build that infrastructure. And we have had a history of mining as long as humankind. In our country, we've had mining over 200 years old, and we still have old mines that have been around for 100 plus years. So there's plenty of opportunity to tackle mine waste because how we mined 100 years ago is a lot different than the technologies and tools that we have today. That said, mine wastes, including mine tailings, they contain minerals that are valuable to the technologies that we use today. And because of, differences in technology back then versus today, we have an opportunity to recover those resources as well as eliminate environmental concerns. And even today, we have many operating mines. We know miners who are currently tossing away valuable metals and minerals from their active projects. So what can we do to unlock those resources and ensure that we are operating those mines as efficiently as possible while contributing to the mineral security at hand? All right, let's step into kind of the bigger picture. Elizabeth, I'll toss it over to you because I think you've done an amazing job on a recent research study that suggested that 90% recovery of byproducts could meet nearly all US critical mineral needs. Can you give us some examples of where these byproducts would be sourced from? What sort of deposits? What is the recovery potential, do you think?
Do you mind if I step back a little bit further? And
Absolutely,
just
go for it.
kind of lay some bigger picture context. So we're sort of already zoomed into this waste to value area where we're talking about critical mineral recovery from mine wastes and as byproducts. I think these are two of what we see in our group as the 6 different supply pathways for critical minerals. One of them is imports, and we know that that creates some geopolitical vulnerability, and there are some supply chain concerns around that. But imports of some things will probably remain an important component for the US. The next would be new mine development, and I think as we think about byproducts, when we begin to develop new mines, there's an opportunity to recover more. We're probably not going to get away from new mining entirely. So, moving into byproducts and mine waste, those are 2 additional solutions. Recycling is going to be important as well. Waste to value, as you mentioned, Bachimeg already, is very broad, and there are lots of other things that could be recycled. But it's sort of a question, is there enough deployed out there to recycle? And probably not right now. And then the last is reducing consumption through efficiency and substitution. So when you think about all of the things that we need, each element or mineral is going to take a different recipe of those 6 different ingredients. And if we move in specifically to the byproduct and mine waste category, I think that the most exciting, most immediate opportunity there is for things that are traditionally recovered as byproducts that maybe we're not going to open a new mine just for gallium. We're not going to open a new mine just for indium or tellurium. Those are going to be recovered alongside other elements. So those are really important potential targets, things that we don't need a whole lot of, but that do co-occur with things that we already mine. And then thinking about mine waste, the accumulated mine waste from mining in the past, those same byproduct elements are important, but also some of the main products that were historically mined, like copper, gold, zinc, for example, have a lot of value left in mine waste. And so going back in and reprocessing mine waste can maybe the cost could be partly covered or even completely covered by those elements, and then that allows us to target a broader suite of elements in that waste. So I hope that I sort of answered your questions. I think it really depends on the particular site as well and the deposit type, but we can go into more geology after the other panelists get a chance to talk.
Wonderful. Ryan, thanks for hopping back on. I'd love to have you do a little bit deeper introduction in yourself and share more on what role technologies like vectors play in recovering byproducts and minerals from mine waste as well.
Yeah, so my name's Ryan Mather. I was trained as an isotope geochemist at the University of Arizona, and I've been in academia for 25 years. We started up a new company, as Bachi Meg mentioned, that's called Vectors, and we serve the mining industry, both from production to extraction and tracing and remediation. And for this application, we provide information about these different types of byproducts that exist out there by giving insights into the mineralogy or where the metals sit in the minerals in the piles. And so that's sort of a very important component to understand, and both from an extraction as well as how much is this pile worth, I guess is one way of thinking about it. And I think that's the added technological aspect. It's beyond typical concentration measurements. And so we do a variety of different isotope measurements, which can enable us to see this sort of aspect in the piles, in the waste products, I guess is one way of thinking about it.
Thank you. It's really helpful. Ty, tossing it over to you. Why is a fishing focused organization like Trout Unlimited interested in mining and historical waste streams?
Well, thank you for asking that question. That's asked of me quite frequently, frankly. Why is Trout Unlimited here? And let me explain. I had already sort of highlighted who we are as an organization, but we're a large national organization with about 300,000 members of our organization around the country and about 400 employees in field offices working around the nation, in particular where trout and salmon exists. So, in terms of what's the connection here, well, first and foremost, I suppose abandoned mines and abandoned mine pollution from pre-regulation mining causes a great deal of pollution, especially in the American West. And these types of pollution sources are heavily impacting where trout and salmon live. And so it's a water quality issue for us. Trout and salmon need cold, clean water, and unfortunately, old abandoned mines have a very large impact on healthy water in terms of trout and salmon habitat. Additionally, and that's part of why we work in the abandoned mine land, AML. You'll probably hear that acronym used today. Why we work in the AML arena is to improve water quality through abandoned mine cleanup projects for the purpose of creating better water quality and habitat for trout. But that also then, of course, provides better water quality for everybody downstream. In terms of new mining and critical minerals in particular, we really started to focus on the critical minerals issue back in 2018-19. In particular, when the first Trump administration put out their federal strategy for critical minerals and put forth a number of recommendations on how we might resolve some of these supply chain issues. And so we started looking into the issue more. And in particular, what we did is we did some GIS mapping analysis of all the known critical mineral deposits as best we could with up-to-date GIS and layers, and discovered that of the known critical mineral deposits in the lower 48, that 50% of them are in current and native trout and salmon habitat, and 1 in 10 were in currently protected public lands, such as wilderness areas, roadless areas, and so forth. So if there is a big increase in domestic mineral production that's done irresponsibly or without good forethought, unfortunately, our user group of public land users stands to be impacted potentially quite negatively. And then additionally, one other item, and you already mentioned this, climate change and water. These metals are needed for climate change mitigation, for green energy, for renewable energy. All of these things are very, very important to us because climate change is impacting trout fisheries and salmon fisheries in a big, big way. So that's why this is really important to us. And we do have mining engineers on staff. We have about 8 or 9, I think, now, including folks in Pennsylvania doing coal cleanups. And most of our staff is out west doing AML cleanups at abandoned mine sites. And that's where we differ from other nonprofits in the environmental realm, as we also work on policy, but we also get boots dirty out on the ground performing abandoned mine cleanups.
Thank you for that. Okay, so one of the things that folks commonly mention around this topic is characterization and modeling of the mineral contents in mine waste. To me, it seems like we have a fairly poor understanding of, where these resources are across the country and the globe, as well as the mineral contents. It looks like last September, the U.S. Geological Survey awarded a couple of $1 million to cooperative agreements to state geological surveys to help study critical minerals and materials and leftover, old mine sites and legacy sites. I've also seen the U.S. Office of Surface Mining Reclamation and Enforcement announced earlier last month, I think, around 120 million in grants for reclamation of abandoned coal mines across the country. So I'd love to just pose the question, do we have a sense of how many active and old mine sites that exist across the country that we could potentially tap into?
I'm happy to jump first, and Ryan and Ty, please join in. We do not have an accurate count right now. I've just been reviewing the new USGS National Mine Waste Inventory, which is coming out of Earth MRI funding, and so far only 7 states have been incorporated into that database. I think the plan is to include all 50. Likely it's over 100,000. One of the things that the USGS has in that data set is volume estimates for different types of mine waste, and so that might be tailings, it might be slags, it might be leaches, as well as waste rock, and there is very little information on what is in those different volumes of material. It's going to be very much a site-by-site question, and even within a site, different types of mine waste have different compositions. So one of the things that our group is doing right now is expanding our estimates from our byproduct study to do the same for all of the mine waste that has been accumulated at sites that have been active in the last 50 years. Going back even further in time, I think, is going to be really challenging, and I'm really glad to see the USGS partnering with state surveys on that. But as far as abandoned mine lands, this is a heterogeneous problem, and there are some that are big, there are some that are small. It's easier to have a good sense of what's happening at mine wastes that are at a site that is still active, because they're collecting data on it constantly, daily, and they have an understanding of what's in the water and what's in the solids and how that may change over time, which can then help us understand what the opportunities are in terms of valorizing that mine waste or recovering metal from it. But I would say, if I could wave a magic wand, one of the things that I would do is remove all sulfides from all mine waste, and then I think Ty would be happy and Ryan would be happy, because Vector's technology can contribute. So turning it over to both of you.
Yeah, that's actually a really good segue. Brian, on your end, what sort of research methodologies and data standards are needed to actually map and quantify and model, these potential supply opportunities? And where does vectors add within the broader picture?
Yeah, so the key thing is how do you characterize a giant pile of rock that no one initially talked about? You kind of have an idea because the deposit it's around, and you have some sense of what's in it, but you really don't 100% know. And so one of the things that we use is we use waters going through the rocks to try to pick up chemical signals in the pile so we can get a bulk sense of what's going on. And so you've got to figure out different ways to be able to sample what are considerably really mineralogically and from a metal standpoint, like Elizabeth said, but there's so many different sulfide minerals that possess the metal that make it very challenging task to be able to say, okay, what exactly is in there? And not everything is always soluble, so it becomes a challenge with, can we look at a composite sample from one of these waste rock sites and get a sense of what's in there? Is that a sensible way to sample it? And then if there is, then how do we scale that up to really large areas? Because as Elizabeth said, some of these areas have very small amounts of tailings or waste rock, and some of them have extraordinarily large amounts. And so that is a challenging thing to be able to characterize chemically to extract all of these different elements that we want out of it. And so we know things are in there. So there's both you can get a bulk sense, I think, by looking at waters emanating from things, and you can also get a detailed sense by actually sampling the tailings themselves in a systematic way. Now, both of them can then be used. You can get chemical data from both of those and then develop models for what you think is in the piles.
Very good. Elizabeth, I'm going to toss back to you. I think in the report you had mentioned that a systematic sampling program is needed to reduce the uncertainty in the estimated byproduct endowment. What sort of government mandates or incentives do you think would be effective in quickly implementing this sort of nationwide sampling program, including at active U.S. mines?
This is a great question, and that is exactly why we proposed that sampling program happen at active mines, because there are relatively few of them. Less than 100 on U.S. federal land were active last year. And so to go in and collect information about the characteristics of the material that's going into the mill and the characteristics of the material that's coming out of the mill and then being stored as waste is a much smaller problem. I don't want to put a systematic sampling of our abandoned mine waste in the too hard basket, but I think it is a much bigger challenge. Simply inventorying where we have mine waste is the first step. Beyond that, I think we're going to have to really identify in two ways, I would say. One is where the real economic opportunities are, and so that's going to be sites with really large volumes of waste, where perhaps there are elements that either weren't fully recovered in the past that have high values, such as copper or gold, for example, or a particular deposit type that's known to be a good host for something that we really need, like rare earths, or the example I gave of gallium or germanium or tellurium. And then I think on the other side, there is the need based framework where we look at which one of these sites and which particular type of mine waste at that site is generating the biggest problem for organizations like Ty's organization. And then we think about, well, maybe it's not huge and maybe there's not a lot of value in it, but if we were to remove all the metals, it would be less of an environmental problem. So there's a lot to do just in terms of understanding what we have and then being very systematic in how we prioritize that. That's something our group is working on. We have different optimization scenarios around the mine wastes that we know about. But even our work is not a complete inventory of every single site because we're only looking at the past 50 years.
There's a question in the chat. Does any country do a good job of mining mine waste?
So we did a study on U.S. companies that are operating in the U.S. and all over the world. And we also looked at several large mine waste reprocessing projects. And the answer is that there's very little implementation. For companies that filed with the SEC between 2001 and 2023, there were only 27 instances of implementation. 72 project sites were clearly and closely evaluated, and only 600-ish mentions of this kind of work in filings, meaning companies are barely talking about it. So that doesn't represent the whole world. That's just U.S. companies that are operating elsewhere. And there are some really stellar examples, but they're a limited number.
Yeah, it sounds like a really great opportunity if no one's really focusing on it right now. Ty, on the policies front, I'd love to have you dig a little bit deeper into this. How are the projects that were making it through the early phase of the Good Samaritan Law currently progressing? I know you've had an active role in that legislation, and so what has, Trial Unlimited learned so far from those early stage projects? It would be great for you to provide an overview of the Good Sam Law as well as the specific projects you're actively pursuing.
Right. Well, thank you for asking about that. We're very proud that after 20 years, we finally got Good Sam to the president for a signature, and we now have a new pilot program under development by the EPA. We are working for the last year with the EPA Office of Mountains, Deserts, and Plains in Denver, who will be administering the new program. And it is still in development. As of yet, there are no projects that have been permitted under the new program. Obviously, the idea here was to remove some of the liability issues that were stymieing third-party voluntary cleanups by organizations such as Trout Unlimited, but also, and maybe more importantly, the state mine remediation agencies who were as hamstrung by the liability issues as was a nonprofit like mine. So the pilot program is for 15 pilots only, and the next, well, let's see, it was 6 years left in the pilot program to get these going. And it has been a challenge. Site ownership in particular has been one of the biggest challenges. As I'm sure a lot of, if not most of the people on this call understand, there is a potentially responsible party at every single mine site in the country. And trying to differentiate through policy those who maybe own a mine site, as an example, a site that was passed down from great grandpa to grandchildren, and they've ended up with a property in the Rocky Mountains somewhere that has some liability exposure because of mine waste, yet they didn't cause the pollution themselves. And so I think one of the biggest challenges we're having right now is working through the eligibility of potential sites to utilize this new permitting program and start to put these projects in the ground. The EPA, we're really close. We think here in the next month, potentially, the program will be fully launched, if you will, with public documents made available for potential Good Samaritans to start to fill out paperwork and bring some projects forward for consideration from one of these permits. I think the challenge has also been, in particular, the environmental attorneys that work for the federal government who have a hard time thinking out the box in terms of CERCLA, the Superfund law. Um, uh, This is a new program. It's brand new. It's never been done before, and the attorneys that are advising the federal agencies on this really have a hard time thinking outside of the Superfund box. And so we're really trying to encourage them to think more broadly about how we resolve some of these issues. So I wish I had more to report on that, other than it is in development and about ready to be launched. And then we'll start to really get into the details of what projects are most suitable under this pilot program.
Got it. So just I guess to put it in the simplest terms, if you have a technology that can unlock critical minerals as well as clean up mine waste, the Good SAM legislation would allow you to have access to mine waste material, but not inherit the liabilities of that project, correct?
Yeah, that's correct. And there are policies in place today that promote non-point source cleanups. These are waste rock pile cleanups and environmental cleanups, primarily involving waste rock. Where we start to get into the real tricky liability question is with point source pollution, where you have a draining mine, where the underground inner workings of an industrial mine complex that's been abandoned is discharging mine water out of the mine adit, and that's considered point source pollution. And as such, whoever chooses to clean up that site, if they were to do so, assumes permanent liability for pollution that they didn't cause. And under the current laws, someone who were going to clean up one of these sites would be required to get a traditional pollution discharge permit and keep that permit for as long as the pollution source continues. The challenge with mine sites is, generally speaking, so long as it rains and snows on the landscape, that water is going to find its way into those mine tunnels and discharge, meaning they will discharge forever and ever and ever. And that's those kinds of a permit for a nonprofit or a state agency really isn't appropriate. So in terms of technologies, boy, what we really need are technologies that are mobile. For one, I'd really like to see more mobile processes that can be taken to mine sites to be utilized and tested at abandoned mine sites. And mobile milling processes would also be really helpful to these sorts of cleanups.
Sounds good. Speaking of technologies, Ryan, can you share more about your recent work on acid mine drainage specifically? And why did you, look into that topic and how is it relevant to vectors?
Yeah, so tracing the source of metals is a key thing on many different levels. Most people want to be able to understand and tie metal to a specific location. And as Ty pointed out, responsibility is a very important thing to be able to understand when you're trying to remediate an area or however you're going to deal with wherever the source of metal may be coming from. And what our technologies do is we can trace metal sources basically at the part per trillion level. So finding most of the time now, when you look at most strategies in understanding what's happening in mine waste or in the mines themselves, they have cutoff. They don't really have cutoff levels for concentration. It's usually just high and low, and then compared to baseline. And we have cutoffs that the EPA makes and everyone else makes. But if you want to look at lower concentration and assign where that copper or whatever lead or whatever metal it may be of interest, the isotopes give you a different level of understanding and ability to see and insight into what the actual sources are. So we have several different customers who are trying to remediate different areas or understand what's happening in their current mine site to understand how they are letting metal into the surrounding area. They know that there's very little concentration increases and they're subtle, and they want to know if they're responsible for that. And as Ty pointed out, everyone wants to know who's responsible for what in each one of these areas. So if you can have a technology that can work differently than typical concentrations like we have with isotopes, it gives a clearer sense, and we can actually tell you the proportions of metals coming from different sites. And that's a very profound thing to be able to do when you want to say, did we remediate this site, and is the metal from this site associated with what's actually in the water, right? So we can more directly tie sources of metal, even in very low metal content solutions, which is also important from the sort of characterization side as well. I mean, you can look at that from a mineral exploration standpoint, or what we described before from a the standpoint of what sits in the pile, even at low concentrations, we can sort of get a sense of what's going on in there. And so, yeah, there's a lot of different types of application and understanding. As Elizabeth said, if we get rid of all the sulfide, that'd be fascinating. But having the sulfide there makes it interesting for me because then we can trace things, right? And so then it gives us the ability to sort of what goes on. It's because when these minerals oxidize and dissolve into solution, they emit unique signals, and it's those isotopic signals that we look at and can use to understand where metal is moving and how it's moving and trace it, right? So that's ultimately a very important thing.
Mhm. Elizabeth, beyond kind of characterization and tracing the source of those metals, what are some of the most significant technological or economic barriers that we have to overcome to achieve even 1 to even 10% recovery of most critical elements in the near term?
Well, maybe before I answer that, if I can just put in a plug for the paper link that you put in the chat. As I mentioned, I've had the privilege of collaborating with both Ty and Ryan in this space, and one of the projects that we've worked on with Ryan is thinking about how to not only use this isotopic information to trace where things are coming from, but then also to better empower and target our recovery. So the paper that is there focuses on thinking about how you would then begin to understand what's happening in a water treatment plant and then actually eventually recover those metals and be able to use them. So it's going to take really smart people like Ryan and the students that we have on board on that project to identify the technologies that help us make this most efficient. But I would say right now the biggest hurdles are economics and policy. So we have plenty of tools that we can use. Those tools could be better, faster, smarter, but we have to make them more efficient so that there's less energy, water, reagent costs in order to do this. For most mining companies, they're not going to go reprocess their waste unless it's economically viable and justifiable to their shareholders. And that makes complete sense, right? You can't force a company to do something that makes the company lose money. So how do we get somehow closer to zero waste mining by recovering more things? We have to make it more economic. We also have to incentivize that. So for particular critical minerals that we may need, where the supply chains may be really vulnerable, we've got to figure out a way to reward domestic operators for doing that in the US. And there's a whole startup community. I see people asking questions in the chat about those technologies, and I know you have people in your portfolio who are working on this in addition to Ryan. And I think developing those technologies and finding places where we can pilot them without liability issues and without huge financial exposure to either the property owner or an operating mine is going to be incredibly essential.
Mhm. I'd love to double click a little bit on your research, Elizabeth. You mentioned that byproduct recovery is presented as a resource efficient approach that leverages the existing mine infrastructure as well as environmental footprint. Can you elaborate more on the potential long-term environmental benefits of a zero waste mining approach? And what sort of achievement could we have when we do have a full byproduct recovery process?
Well, if we were recovering everything from a mine, if it were a metal mine, we'd be pulling out all of the metals and finding uses for those, and then we'd be left with still a very large volume of waste that's mostly silicate minerals that could be repurposed as from everything from frac sand to creating glass for wallboard. So we have a colleague, Priscilla Nelson at Colorado School of Mines, who works on tailings to glass as one example. But that's where the largest volume of that material is. I think if we can ensure that that material is inert by removing all of the metals, then we've really done a great thing, because the large volume can be repurposed for all kinds of construction and infrastructure purposes. We're a long way from doing that, because right now we, as a society, the way we use things, we skim the cream off the top. And we're used to, as consumers, paying very little for goods and not paying for all kinds of externalities like the eventual contamination of a watershed. And so thinking about how do we really readjust our economic framework so that it becomes important to recover all and use all from the material that we mine. We're a very long way away from that. Did I answer your question or did I just kind of sizzle around it?
No, I think you did answer the question. I think we're all in alignment of where we think the industry should be long term. I'd love to actually have Ty chime in on the benefit side. If we had a zero waste mining operation, what benefits is Trout Unlimited interested and excited about?
That's an interesting question that I haven't really pondered before. I get so focused on the legacy sites, on historic mine waste, that I don't often dive into these sorts of topics. But certainly, as Elizabeth has described very well, if we can mine better, be more efficient, be more effective in the way that we mine as a nation, whereby producing less waste that is causing or potentially causing environmental damage, that's certainly a good way to go. But, I know I mentioned this before, but I want to make sure it's clear. Really, where we focus our efforts are on these abandoned mines that were operational before modern environmental laws. And that's really where our focus is. So I'm not as well suited as my colleagues here on the panel to talk about current mining operations as much as how we can be better about cleaning up the mistakes of the past. And I will note, because the financing of all of these sorts of things has been part of the conversation, that one of the biggest challenges that the state agencies and groups like mine have, outside of the liability and policy challenges that we have in front of us and are trying to resolve through new policies such as Good Samaritan legislation, is how do we pay for these cleanups? These cleanups are done out of the goodness of our heart. We're not doing it to make money. We want to make sure that we cover our expenses, but it's not a profit-oriented endeavor. And the only way that we're able to do these abandoned mine land projects is because funding that's made available through contributions and donations. In particular, for my organization, almost all of our projects are funded by the mining industry themselves. Groups like Newmont, Freeport-McMoRan, Kinross, as an example, who feel an obligation as a modern mining company to help correct the mistakes of the past. And as such, they provide funding to us to clean up projects that are not on a site they're responsible for, right? They're able to bring money to the table and help correct the mistakes of the past by providing funding. So I just wanted to point out that it's not just funding that's needed for new technologies. Even with the existing technologies we have today, there's just not enough funding to pay for these massive, massive cleanups that need to occur to really correct the water quality problems that we have.
Mhm. A Christian dropped a question in the chat here. Obviously, regulation has evolved over time. We talk with large mining companies that are navigating perpetual water treatment in some sense, which the costs can continue to go up if you're talking about forever. Um, so Christian's questions, how could the operator manage liability for legacy issues? Any thoughts there?
I mean, how would you manage liability? You really have to characterize the site before you start,
Hmm.
right? I think that would be a way in which you could manage the liability if you understood how things started before you started doing things there, right? Because as Ty pointed out, you're responsible for that point after. So characterization of what sits at the site before you do anything is key and is going to control the liability and the issue. I think that's what the question's after. That's how I understand it, at least. Yeah.
Hmm. Very good. Okay, I'm going to segue into a bit of the questions that founders typically ask. So if you were a founder and you had a technology that could work on an old mine site, where should they start? Do you just show up at an old mine site?
Well, no, that wouldn't be the right way to go. Bringing new technologies to bear has been a challenge that I've encountered, and you asked earlier about some of the challenges that we encounter, and that is one of them. And let me give you an example of that. It's hard for new technologies to take bench scale technologies and take them out into the field to test them under real world circumstances. But again, the liability laws have made it such that everyone's fearful of permanent or some level of liability for pollution. And so I have argued for in particular at the Bonita Peak Superfund site in southwest Colorado, where they're in the process of developing a new or building a new treatment plant to treat mine water. That there be a place where these new technologies could come, be supervised by under CERCLA liability protections, whereby they can test these new technologies upstream of a wastewater treatment plant, such that that effluent water whether it meets water quality standards or does not, would be able to be run through the treatment plant at a Superfund site to ensure that as it's discharged out into public surface waters, that it does meet water quality standards. And so I would say that the answer to that question is are the folks that are performing these abandoned mine cleanups out in the field, such as ours and state agencies. That's one place to start. And then there's, of course, at the EPA, they have technology offices and research and development departments where these types of emerging technologies can be brought before those scientists for further evaluation and study.
Another approach is you can actually go to the mining companies themselves. A lot of the mining companies are actively wanting to understand what happens with them. And so a lot of our clients are the mining industry. They want to know what's going on, and we give them different perspectives. So I think in order to get technologies off the ground, sometimes you got to just kind of keep your face keep in their face a little bit and keep persistent. And eventually, you start to get some breakthrough. I think that's the key thing. And we have, I mean, we've done work with government agencies. I've done a lot of work. I mean, as a company, we've done a lot of work with government agencies, and that's great. But I think the greatest application in the ability to apply the technology is if you show the mining industry how it works, and you do that directly. And I think that's the best way you can make a change, in my opinion, to show them how they can use it, and then they can. And I think that's why we've really been trying to do that, at least the way we've been approaching it.
Yeah.
Can I chime in?
Yeah.
I mentioned from the university perspective at Colorado School of Mines, we are in the process of developing a model for something like a hub where various organizations can come in and work with us on scaling up technology. So I think you'll see more about that in the next couple of months. But having that industry, so mining company, academic, startup partnership is something that I think all of our organizations can help facilitate, and it's a model that we all believe in that really helps bring new technologies to the stage where they can be applied to these problems at scale.
Amazing. On Nomadic Venture Partners side as well, we launched a program last year called the Mining Water Tech Pilot Pathway Program to help technologies deploy on mine sites as well as old mine sites. So there's new resources that are continuing to pop up across groups like ours, as well as other, national labs, universities. There's significant opportunity that's to be had in terms of coordinating even water or, tailing samples that we can distribute to technology providers as well. Ty, what kind of regulation do the founders need to be mindful of when they're tackling mine waste? And then how should they also engage with local communities, you think?
Yeah, it's interesting you pose that question about engaging with communities. My first thought on that was I'm not sure that those technology companies are the best folks to be out there talking with communities if they're pursuing these new technologies. Um, so I sort of wondered about that. Um, I mentioned this a moment ago about the portability of technologies, and that's really one of the challenges that we face out in the field. Because many times we're cleaning up these sites that are quite small, and we don't have the ability to economically ship or transport waste off to wherever a mill might happen to be to utilize that. So that's one of the things that I'm really hopeful we can work on. But in terms of policy, one of the most important things that I think that the mining industry can do is to try to win back social license of the American people to mine in the United States, which is challenged after 150 plus years of unregulated mining. And in particular, I think reform of the 1872 mining law to bring it up to date is certainly one of our top priorities. That worked very well in 1872 and for an awful long time, but it may not be appropriate today, and that's our opinion. In particular, royalties are not charged for extraction of minerals on public lands. And that leaves us again back to this concern that we don't have dedicated funding made available for abandoned mine cleanup work. And that's one of the ways that we can fund this is having the mining industry for extraction on public lands to pay a royalty and have that money directed to a dedicated source where state agencies, tribes, and NGOs such as mine can access them.
Mhm. Okay, I know we're getting fairly close to the end of our time here, so I'm going to segue a bit into some of the Q&A that came through in the chat as well as the Q&A box. Let's see. Is there a case study or can you present an example of how an operator could begin to operate on an abandoned mine property? What are the existing federal programs they could work under? What new potential programs are there, and how would this aid the process?
Ryan touched on this a minute ago. When it's the liability issue. It's the ownership of the responsibility of the pollution. And when you start to have these legacy sites intermingling with active mining sites, it's challenging to differentiate where liability may or may not exist. Under current regulations, if a mining company were to take ownership of a legacy site, at that point it ceases to be a legacy site in the sense that it now becomes potentially feedstock for a mining for a modern mining operation, and that's a completely different animal.
We've also been working with kind of exploration stage mining companies who are near a brownfield site. They're operating in an old 100-plus-year-old mine site that has existing tailings and actively looking at ways to leverage that as a potential resource to develop infrastructure locally as well as have them, leverage new technology to be able to tap into some of the critical minerals that are in that waste stream. There are active funding opportunities with the Department of War, DARPA, and others. I know Department of Interior has also been working on a number of efforts around this. So I think there's significant opportunity for public-private partnerships in this area as well. Okay, Grace asked the question, what are the main cost hurdles that mine recovery technology has currently? Ryan, do you want to take a stab at that one since you're running a technology company as well?
That's a good one. What's the cost hurdle in order to make all of this happen is wow, that's a loaded question. I haven't really when I saw these one in the chat, there's some really good questions here. But yeah, so I mean the I don't know necessarily if it's always a question of if there is funds to make things happen, if it's you're talking to the right people to make it happen more. I don't know if that sounds right, but a lot of things that I found when we are trying to do things with a variety of different people involved, it seems not a lot of times it's the money that's a question. Sometimes it's the ability to communicate things and people to understand that your technology is useful, right? And I think that's one of the biggest challenges that technology companies have is, and when you're trying to sell things and you're trying to show different ways or different ways of thinking about them, it becomes very challenging for people who are accustomed to doing things certain ways. So when you ask the question, what is the hurdle necessarily money? I don't know. A lot of it's also concept and how people perceive things, and in order to get your technology adopted, those are big hurdles too. It's not always just money. So I think that's another when we think about trying to make this go, you have a liability hurdle, you have a technology hurdle, and you have to have people understand and learn and be appreciative of all those things in order to make things happen, because I think there are, as you pointed out, Bachime, you just listed out like 8 different governmental things where people are giving away money to do things, right? So, I mean, and that's great. And you can have lots of great ideas, but at the end of the day, I think it really is, from a technology perspective, being able to teach people how useful your information is and how that can be adopted. And those are the key things, in my opinion.
Hmm. I would double click on that and say it's also a matter of talking to the right people within the mining company as well. You could be talking to folks who are only caring about increasing their recovery. On the other side, you could be talking to somebody who is on the mine reclamation side and they're trying to reduce the liability. So really making sure you're talking to the right person and positioning your solution in the right ways is going to be critical. Okay, I'm going to pop into the Q&A and maybe I'll start from the bottom here. Hong asked, is the federal or local governments doing enough to clean up the legacy mines, or are they just leaving it to local communities to deal with it? Are the governments also allocating sufficient funding and resources to solve these problems? I feel like we could all be doing enough, doing more. We actually visited an old uranium mine site in Colorado last year, which was quite eye-opening. There's, significant potential for uranium to be recovered from that old mine waste, but right now it's just being stored, and they're treating the water, obviously. So I think there's significant opportunity to coordinate between technology and innovators to tackle opportunities to go after those mine waste streams. And that means actively, communicating with state level organizations that have oversight over some of those resources and actively opening a dialogue with them. And I think they're very open to hearing new solutions to clean up mine waste as well.
Could
To
I?
partly answer, oops, I'm sorry, Elizabeth,
Right,
go
Ty.
ahead.
I was going to ask if I could maybe draw a clear distinction for all of us. I think there's a very serious difference between applying technologies to cleanup of abandoned mine lands, where I think the liability provisions and Good Sam are probably the biggest challenge, as well as funding for that reclamation activity. And then cleaning up mine wastes that are either owned by an active mining company or are actively being generated. And for those companies, it is a liability concern and it affects closure and disclosure in a way that I think requires a different case to be made, and maybe more de-risking in order to justify it to that company. And I think that's where having the opportunity to sort of practice scaling up some of these technologies in a safe way and then having that data to then show to a company is probably going to be the most important.
Thank you. Hi, did you have anything else to add?
I was just going to say that really the only program that we have outside of the brand new Good Sam law, which again is just being developed even right now, the only tool that we have at our disposal at the federal and or state level to clean up abandoned mines and legacy mine sites is CERCLA, the Superfund law. That's the mechanism by which in this country we clean up abandoned mine waste at a federal level. Superfund was never created with mining sites as the primary target. Superfund was created primarily for toxic industrial sites, and we're utilizing it as the only tool that we have in this country to clean up abandoned mine sites. It's kind of a round peg in a square hole situation, and while it works, it doesn't work as well as it could. And typically, CERCLA is only employed at sites where there is a potentially responsible party where compensation can be sought. And so that greatly limits where CERCLA cleanups could potentially occur because typically the federal government's going to use CERCLA where they can recoup some of the expense for the cleanup from a responsible party. So the idea with Good Sam legislation was to provide a new tool that fills that gap. Only the worst offender sites in this country, mining sites in particular, are listed under the national priorities on the national priorities list and pursued for federal Superfund cleanups, which leaves, we started this conversation with talking about these massive numbers of abandoned mines in the country, quite frankly, and I'm just going to throw a number out there to give a sense of this to the participants here today. 98% of those mine sites, those abandoned mine sites out on the landscape, would never qualify as a Superfund site. So the only tool that we have available to us really right now is not sufficient, and it's not being employed as broadly as it could be. And so again, Good Sam was attempting to try to provide at least another tool in the toolbox for these abandoned mine sites. Our policy work that we do along the lines of abandoned mine sites is to promote cleanups, to try to provide any additional tools that we can to address the problem, because CERCLA just isn't the right tool in most cases.
Thank you. Um, Looks like Mike asked a question on how is it possible to find out what mine sites have tailings that contain interesting critical minerals that are worth recapturing? Is there an inventory database that would indicate what is potentially available?
That's where we started this conversation. That database is under generation. It's going to take a really long time to have comprehensive data. And that's why we started with byproducts from 50-ish active mines. Now we're looking at 323 mines that were active in the last 50 years. Scaling that up to the hundreds of thousands of sites, especially including abandoned mine lands, is going to be a really long-term project. So I don't think that for those, call it 100,000, we're not going to have a priority ranking and optimization matrix set up anytime soon. Data are being collected, and technologies like Ryan's can certainly help. But I know, Ty, that's not how you approach your site selection, right?
It's not. The state of Colorado is pretty lucky in terms of a state agency doing some sort of a abandoned mine site inventory. The state of Colorado has done a better job than most of the other states, and that's because after the Gold King mine spill in 2015, our state legislature in Colorado allocated money to have the state agency perform an inventory, and it's not complete, but it's one of the most comprehensive for any state that we have. And this goes right back to money. The state agencies are not funded well enough, nor do they have the capacity um, um, to do this at the level that it needs to be done. And so, when it comes to policy recommendations, one of the policies that we really promote at the federal level is providing money to do these inventories, to fund these state agencies, to fund others to better characterize these waste rock piles so we have a much better sense of what the problem is more nationally. For us as an organization, we choose mine sites that are the projects that we do are Good Samaritan projects, if you will, are not done on public lands. They're done on private lands where we've worked out an arrangement with a willing landowner that'll let us onto their property to do these kinds of cleanups. So it's a really unique place that we have found and are able to work in that even the state agencies can't do.
I will drop a couple of links in the chat here. I know our friends at USGS are actively also working on some of this work as well. So keep an eye out on their websites for some of the inventory related questions. And I'm sure Elizabeth, Holly, and team are actively working behind the scenes as well. I know we're up at time, so I really appreciate you all joining us today. I'm sure we can have another hour on this discussion. I apologize we didn't get to all the questions that came through, but really appreciate you all joining and spending an hour with us on this important topic. And I look forward to the next iteration of this conversation soon.